Okay, good evening. It's the last talk, right? Everybody are tired, so try to be another half an hour kind of. It's a lot to process, so I'm going to go over about. It's a lot to process in half an hour, so I will go over the different components in a very basic level. So the main objective is to give you or to explain the motivation behind the different components, and you can later on decide if you use them or not. So a little bit about myself. My name is Omri Erez. I live in Hamburg for a long time, almost 10 years. I'm a freelancer. Mostly now I have one client called Radio.de. It's a company here in Hamburg. And in parallel, I'm a published author for a platform called Pluralsight. I'm producing online courses about Android development. And in my free time, I'm organizing some blockchain meetups here in Hamburg. If you're interested in blockchain, you can come to me later. I see some familiar faces. Yeah, so this is me. The agenda for the next 40 minutes, as I said, it's a lot to process, a lot of information. So I'll try not to go too deep because we don't have much time. So first of all, introduction about the common patterns that you might know. I'm sure every one of you used in your implementations. Then we're going to start talking about the R components, which we're going to start with the lifecycle aware components. Next, the ViewModel, which is another new component from one of the libraries. LiveData, and the persistent solution Room, which Serge already gave us a pretty good introduction. I will cover it. I really like Room, actually. It's good for a lot of use cases. We'll talk about it a little bit later. Okay, so why is architecture important? We all know that. We as developers, we all the time trying to write our code with a structure or with a certain architecture. There are a lot of different approaches to that problem. Some common patterns that you all know. So before the pattern, so the importance of architecture is basically, or as I see, the most important factor of having a structure or an architecture in your implementation is that all your developers or all the development stakeholders have a common understanding of what's going on, right? So if everybody knows the structure of your app, then it's much easier to extend it because everyone are on the same page, basically. And of course, we all want to be good developers and produce testable and a relatively easily extendable code base, which is very important, especially if you are dealing with long-term projects. Then it's important if now your application needs to be developed over a couple of years. If you're building a prototype, then basically you can just build a prototype with one very long activity GAD class that has all the components and all the logic within it. So it's more important for kind of maintaining a long-term project. Yeah, so this we want to avoid, right? So if we write a prototype and all the logic is coupled within one very, very long activity, which is called a GAD class, for example, or spaghetti code, that you want to avoid, right? Because it's very hard to test. You will sooner or later encounter problems. And when new developers will start working on your project, they will be kind of lost. So what we want to aim for is something like that. It's an app with different layers, that each layer can be separated from each layer is separated from the other layers, and each layer can be testable separately. Common patterns that we all know, so we know MVC, MVP, MVVM, and actually Yossi in the last meetup here in Hamburg presented us with the MVI, which is the model view intent. I'm sure everyone used or implemented one or more of these patterns. I'm not here to tell you what is better and what is not. It's basically depends of what you're feeling more comfortable with. Another approach is the clean architecture, which is kind of reinforcing the solid principles for design, object-oriented design. Does it sound familiar to some of you? Okay, that's good. So it's enforcing the solid principles, which are 5 principles for kind of writing object-oriented software and to make it more testable, and each component is decoupled from the different components. Basically, just guidelines for object-oriented software or for implementing well-structured object-oriented software. And it contains 3 layers. Now, this is a topic by itself, so I'm just going to talk about it very briefly. But in the clean architecture approach, especially in the Android context, your app will have 3 modules or 3 layers. The first one will be a presentation layer, a domain layer, and a data layer. And each layer would be, it would be possible to test each layer separately. The presentation layer will contain your Android components, and for example, if you're using a model view presenter or MVC or some of the other presentation layer patterns, the domain layer will be the layer that will be without any Android API, so it would be a purely Java library. So you would concentrate all the business logic of your application inside domain layer, and theoretically you could take this domain layer and copy it to a different application. Let's say if tomorrow you want to implement a web app using Java, then you could just take this layer, all the business logic would be reusable, and the data layer will contain all the data-related components, which there, of course, you will need some kind of some Android dependencies if you're using some native APIs, if you're using some other third-party persistent solutions like RealM or SQLite or whatnot. Now, this is another approach. And the big question is, what should I use, right? So there are profits for all the different architectures. Some people say the clean architecture is the best. Some people say we want to use only, I think that MVP is the best, and really want to use only that. And the right answer is that there is no right answer, right? It depends. Each project and its conditions, so there is no right answer. If now you have a development team of 5 Android developers, and your current project is heavily using MVP, then of course you're not going to take this project and rewrite it to use some other patterns because it's economically not feasible, basically. And actually there is no reason to do it. In addition, if a new developer will come to your team and everybody are really familiar with the MVP pattern and it's been heavily used, then the new stakeholder, the new developer will have to kind of learn how it works, learn the structure, and go into kind of the common working scheme, if you want to call it like that, or the common, how do I call it, the common working processes or rules that you have inside your application. So we have to find the sweet spot, right? Because if you are using one kind of architecture or a different kind of architecture, you can or your architecture can be really complex, but then there is always a trade-off. For example, I built some projects with the clean architecture, which as from a point of development effort, then at the beginning it has some overhead because you have 3 different layers and a lot of abstraction levels, but then I found out that if I explain this architecture to new developers, then it's really easy to extend, and actually the ongoing development is easier, is one example. And so we really need to find there's always a trade-off, and we really need to find a sweet spot between well-structured and well-defined layers, and of course development and kind of cost-effective development. And for that, Google introduced a set of support libraries, if you will, that's called Android Architecture Components, or ARCH, and we'll just go over the different components. So the first component is lifecycle aware components. In the short is LCA. Every time I say LCA, then you know I mean lifetime aware components. And basically, usually if we have an Android, let's say we have an activity, and we want to get some location updates, then we always have to have some lifecycle, we always have to have lifecycle related logic, right? Because if we register some listeners, then we always need to make sure that before our on-destroy is called and the operating system is killing our activity, we have to clean the reference, or kind of to unregister our location listener, because if not, then the activity will be leaked. So there's always kind of logic that we need to implement within our activity. And this can result in long lifecycle callback methods. So if we have, let's say, 10 different components in our activity, and each one of them we need to clean or to register, unregister, to clean or to initiate, then we're going to end up with a very long, let's say, on-create method or on-destroy method and so on. we have to clear the resources properly because from what I said from before, if not, then our activity probably will be leaked sooner or later. And all the lifecycle dependent logic is going to be part of our activity service or fragments if you use them. Now with this new framework, with the lifecycle aware components, we are moving all the lifecycle aware, all the lifecycle logic or lifecycle related logic to be part of the component itself. So we are ending up with really nice structured components. I will show you exactly what I mean. And our activity lifecycle callbacks, so our fragment lifecycle callbacks are actually being minimized. And sometimes you don't even need them anymore. So this is how it works. This is actually how it works from AppCompat 26.1. So you don't need, it's part already of the AppCompat library, so you don't need any external dependency. And the AppCompat activity is going to be a lifecycle owner. And we have our component, which will need to implement an interface, which is called lifecycle observer. And every time we want to register on the lifecycle, on the activity lifecycle events, callbacks, we will just register or add an observer to that. And every time one of the activity lifecycle callbacks will be fired, then we will use the on lifecycle event annotation in order to trigger our respected code. It's pretty simple. This would be one example of that. So here we have the activity, and we have our LCA component. You can see here that we just, can you see it properly? Like maybe we can dim the lights. I'm not sure it's going to work. But you can see it on the back. It's fine? Yeah? Okay, great. So here we're just going to pass the lifecycle object. And this is our lifecycle component. And we just add the observer here. And as you can see, we have the respected on lifecycle event annotations. And for example, when the onCreate is being called, then let's say we want to do some initialization code, you have a possibility to register on all the different callbacks together as well. And this is another example for registering for the onDestroy. Now, I checked before the talk today. So all the callbacks will be called before the before like the activity itself is being called. So before the onCreate or before the onPause method is actually being called, except of the onDestroy one, which kind of makes sense because you want to release all the references and all the resources before the onDestroy is being called in order to prevent the activity from being leaked. Now, the second component is the ViewModel. Now, the name is a little bit confusing because we know the ViewModel from the MVVM as well, but you don't have, like, for example, the MVVM pattern. Usually, you're going to use it with the Google Data Binding Library, but here it's kind of a little bit different ViewModel. I will explain in a minute what exactly I mean. So we have a diagram of the simplified activity lifecycle. So we have the onCreate as usual. Then we're going to create our ViewModel, or if we're using MVP, we're going to create our presenter. If we're using a Dagger or a different dependency injection framework, then in this point, our presenter will be injected. Then we have all the different lifecycle events, and our presenter or our ViewModel will be kind of alive. And on the onDestroy, it will be destroyed. Now, in that scenario, if we take our MVP or our presenter scenario with Dagger, then what's going to happen if there is a configuration change and now the activity is being recreated, then Dagger will re-inject the presenter, right? So every time the activity will be recreated, then a new presenter will be injected or will be created, which can be a problem because if your presenter is really bloated or like it contains a lot of different components inside it, and it can be really heavy for memory. So it can hold a large amount of data. Maybe it contains other components, and it can have a relatively large memory footprint. Now, if you're running your code on a Google Pixel, probably the user wouldn't notice that, but if you're running your code on low-end devices, then probably sometimes this process can be heavy. And by the way, your users probably don't care if you use anything of that as long as the app is working, right? They don't have any idea if your app have any architecture or not, as long as the user experience is smooth and everything is working, but it's kind of in terms of development, we're trying to get the best cost-effective solution. So without using the Arch view model, we're gonna, let's say our presenter will be created every time the activity is recreated. We need to take care of saving the state. So if there are some user states within the activity, we'll need to save them somehow. And it can be relatively wasteful in terms of memory. Now there is a very old mechanism actually in Android, right? So we have a mechanism to save the state using on-save instance state and on-restore instance state, which I actually didn't use for a very long time, but it's there, it is intended to use. But this mechanism is not really intended to be used with very large data sets. So if you have a lot of different states or a lot of different variables you want or large data sets, then this is not the right mechanism because it's not very good with large data sets. And with the new view model, the view model is created only once. So even if now the activity will be recreated or your fragment will be recreated because the operating system decided to do so, you will still use the same instance. So it's been created once, and you could actually use this view model to share data between fragments or, let's say, activity. If you have an activity with a couple of fragments, then you can still use this one instance, which in terms of memory is more efficient. And it can be shared between the activities and fragments. And the operating system will retain this instance until it decides that it's not needed anymore. Or it will save it to within the entire life cycle of the intended component, basically. So this would be an example of how to get this view model. I have a class myViewModel, and we're calling a class called ViewModel Here you can see that we are actually we are passing the lifecycle owner. So this is how the operating system knows, okay, this view model is related to this activity. And this is a very unattractive view model because it's empty, but in general, so we're going to extend the view model. There we have a kind of a default constructor. And another nice thing about it, if you are familiar with RxJava, then usually, for example, if you're using subscriptions in order to subscribe to some data sources, then here you have a built-in callback, which is called onClear. The second that the operating system says, okay, I don't need this view model anymore, then it sends a callback, and this is actually the place where we can dispose all the unnecessary subscriptions or stuff similar to that. It doesn't have to be with RxJava, it can be with other data sources. The point is that we always have some kind of clearing logic, right, in a lot of cases. And the operating system gives you a mechanism to know, okay, now we need to get rid of all the unnecessary resources. Very important, because the view model is being retained, because it's created once and it's being retained over the life cycle of maybe a couple of components, it's very important not to, or to avoid having some references to an activity because, again, it can create a memory leak, especially not static references, of course, which is anyway a bad idea in any context, by the way. The third component is LiveData. I think this is my favorite from all of it because it's kind of a light version of RxJava. I want to think about it like that. It's pretty simple to use, and the framework itself is not very, in terms of size, it's very compact, actually. So LiveData is a new framework of basically getting data updates asynchronously, it's very similar to RxJava, and can be used in combinations of our view models, the component from before. It's basically an observable data holder, and it's using the observable pattern. And it is a lifecycle aware component as well. Then it's been combined with the lifecycle aware APIs in order to kind of keep the live data object within the lifecycle of the intended of wherever we use it. Now here you have two ways to register on updates actually, which I will show in a second, but LiveData will shoot the updates or will send you data updates only if the activity, let's say, or fragment is in an active lifecycle state. So if you are registering on a LiveData object updates, data updates, and now there is a change in the data set, but your activity now is, the operating system decided to destroy it, then you wouldn't get the updates anymore. This another, I came up with this sentence alone. Okay, so LiveData allows async data access and decouples, and this is a very important part, and decouples the access of our data from the component who consumes it. So you can share the different LiveData objects between different screens, for example. And this would be an example. Here you see we have a LiveData object, which is a mutable LiveData of type a list of one model. Let's say it's a very simple model, which we later want to show on a list. Here we have one method, which is updating the data. Here, let's say we're fetching the data either from a database or from a network or from a local storage or even from a JSON file, whatever, each data source, and it doesn't really matter. And in order for the observers to get the update of the data, we just need to use the LiveData method setValue. Now there is a difference. If you're calling it from the main thread, you need to use the setValue method. But if you're doing some background work, let's say now you're getting data from a remote API, or you need to do some heavy mapping, then you have to, and if you're calling it, or if you're updating the value from a background thread, you have to call the postValue method, and the operating system will actually note you on that, so it will crash. It will tell you setValue is not allowed, is allowed to be used only from the main thread, so it's very, the exception is very clear to understand. So after a couple of times, you kind of get it because it's really readable, yeah. And how do we register for these LiveData objects? Again, it's pretty simple. So we have our ViewModel from before. Then we're going to have an observer of the same type. And here we have the getData method, which is exposing the LiveData object of this type list of our, the list of our model, of my ViewModel, not my ViewModel, my, where is it? Yeah, this is a mistake. So this is a model, a data model, okay? So we just observe, and again, we will define the lifecycle owner. In this case, it's our activity, and our observer. And every time we're going to post or set a new value to this kind of data stream, we could just update it here in our list, adapter, or whatever you use in order to show the data. Recycle view, or whatever you use usually. Now there is another variation of that, basically. So if you're using just the observe method, it will be binded to the lifecycle owner. In this case, it's our activity. And if now our activity is not in an active state, let's say the onStop was already called and the activity is on the background, then even if this data stream is being updated, then this observer wouldn't get the update anymore because the operating system knows, okay, anywhere activity is in the background, it's not needed to get the data updates, then it just ignores it. Now, let's say you have a service which is long running and you want to get the updates always, then you would use a different method to register on the data stream updates, and it would be the observe forever method. Again, we're going to input our observer, and in that case, it's just really important to remember to remove the observer as well before our activity, in this case, is being destroyed, because if not, again, the activity will be leaked. If you're in a service and as well on the on-destroy or the on-stop, or before we know, or before we're sure that the operating system is going to kill our component. As you see, it has a really simple structure, actually. Another functionality is that if we compare it with RxJava, for example, then in RxJava you have a very powerful operator, which is the map operator, right? So you could, in a lot of cases, you need to map different objects. So let's say you get some entity from the network, but you don't want to that your adapter have this heavy entity, then you're going to map it to kind of a simplified model with only or a light version of the full entity in order for the UI to be kind of, in order for the adapter to be lighter. Then there are some built-in classes for that, a transformation class. So you could input a LiveData object with the input of this list, and then define a function in order to map it to a different model. Last time I checked, this code is actually running on the main thread, which is kind of a bad idea if you have heavy mapping or if your mapping is relatively heavy. So we would probably need to extend that to some kind of an implementation with a background thread, executor, stuff like that, in order to make sure that all this data mapping is not being done on the main thread in order not to block it. But I guess for very simple mappings, it should be fine. And there is another class called mediate or LiveData. Here you can basically add multiple data sources. Okay, so let's say you have an API request and you have local storage as well, and you want to register updates for more than one data source. So you can add different LiveData objects that every time that one of these sources will be updated, our observer will get the update. It's kind of the merge operator in Rx. So you could get the data from multiple data sources and decide that you will get the emitting values every time that one of the sources is being updated. And of course, everything is very boring without data persistence. So Serge talked about before about Room. Usually, if you use the native database implementation, the SQLite, then you probably create a database. And then you're going to create a SQL helper. And then you have some additional code that you need to map between the cursors and the Java objects. If you want to expose your data to different apps, you're going to build a custom content provider. Or if you have some complex operations, then you're going to anyway going to implement the data provider. And the migration, if data changes, as we know, in the normal SQLite, it can be relatively ugly. And it's not nice. Like, you need to take care of a lot of stuff. Then Google came up with the persistent solution Room, which is kind of a light version, kind of a top level on top of the SQLite, which is very readable, very easy to use. I really think that, like, for most use cases, it's enough, because probably like 80 or 90% of the apps out there don't really have to deal with really complex queries or complex data structures. Most of the apps probably don't have 1,000 or 2,000 or 10,000 entries in their database. So definitely for prototyping and kind of for simple use cases, I would say that here, like, the trade-off is pretty good. So it's very easy to use and takes, as Serge said, like 15 minutes to implement. Google warns that it has some overhead in creating the database, because of course, the more top-level components that we have, there is some more kind of code generation and some other processes, internal processes involved. Then they just warn to use a singleton, just to make sure that you're using only one instance of the Room database, because it can be heavier than the native SQLite implementation. It uses annotations, as we saw before. And I think one of the biggest advantages of that, especially for developers that kind of beginning with Android, is that Room has a mechanism of basically it will validate the SQL queries that you're doing within the annotation. So if you're doing some errors, or if you're trying to query a table that you didn't define, it will let you know directly. What happened or usually when you implement a native SQLite, then you can get some runtime errors. Like if you have some SQLite statement errors, then you will find it out only on runtime. It will tell you I couldn't find the table, or I couldn't find the column. And here it will kind of pre-compile time. It will let you know if you did some mistakes. So it's really, really useful, especially for beginners. It's relatively easy to test. As Serge said before, there are a couple of APIs to initiate the database in memory, and provides easier migration APIs than the native SQLite. And it actually has only 3 components, which actually the first time I saw it, I was amazed how simple it is, because it's really simple. So you have the entity itself, then you have the data access object, which is a DAO, and the Room database, which is kind of standard implementation, so it's a no-brainer. You don't really need to think there too much. And it would be an example of an entity. So here, for example, we have a table name called products. We define a primary key. We can say that the primary key can be auto-generated as well if we want. If we want to override the column name, then we can just use the column info annotation and just override the column name. If we want to ignore some, if we don't want to persist all our attributes, we can just use the ignore annotations, and there are more annotations. I'm not going over all of them, but as you see, it's pretty simple. Another example would be, we can define some foreign keys, so we can define some relations between different entities. And here you can actually define indexes. So you said before that it's not supported, but I'm pretty sure it's working. I'm not sure it's working as natively it's going to work. Like, I'm not sure if internally it's working as the same as the normal SQLite indexes, but this annotation is there for some reason, so I want to believe it's working. What else here? For example, you have the auto-generator. It's pretty standard stuff. You can check the documentation. It's very good, so there are some different annotations you can use. You can as well define composite indexes. So if you want to have an index which contains more than one column value, then you can do that as well. This would be an example of the DAO, of our data access object. You can, for example, define a conflict policy. So for example, here you see we have the insert. We're inserting the list of entities, and what if our database already have these entities with these primary keys? Then usually if you use the native SQLite, it will throw a conflict. And here you can say, if there is some kind of a conflict, which will, in insert probably, it will be some conflict related to the primary key, then you can just replace. So there is a conflict strategy, which is pretty powerful as well. As well as I said before, you can enter here some, if you want to query one product ID, you can just enter it as a parameter, which is pretty powerful. And if you're doing any mistakes, then Android Studio will directly throw an error and say, listen, you are trying to query, or you are trying to select columns which are not defined, or tables which are not defined, and so on. So it's pretty helpful as well. It has a built-in, if you're using RxJava, so it has a built-in support for RxJava, as you see here, for example, the flowable, which if your project is using RxJava, then it's another kind of advantage to use it because it contains the support for that as well, which is pretty nice. And this would be an example of the database object, which of course it's an abstract class, which extends the room database. Here we see that we have two different kind of entities, the version, and you can even define data converters. Then let's say you want to store a timestamp in your database, and probably in your database you would want to just store it as a timestamp, as a long. Then you can define, okay, this I want to get it as a date object, a Java date object. Then you can just define a data converter, and Room will convert it automatically for you. Then we have to expose the DAO objects. It has to be abstract as well, because then internally Room will generate the code needed for that. And these both methods would be basically the entry point of accessing our data. And actually there is nothing more there. Here you see we are making sure that we have only one instance, but it's pretty standard code actually. And if we want to access the data, then we will call our database, call our DAO object, and load our product. You see it's supporting LiveData as well. So it's intended to work together, which is quite useful. And here the same for the comments. Now it has built in for all the standard operations. So as I said before, like most apps don't need more functionality than that. And the amount of data that most app has like persistent, the amount of data that most apps are actually persist on a database is not very big in most cases. So it should be a very sufficient solution from my point of view at least. And if we take all the different components and use them together, Of course, you can always make your architecture more complex, and you can use more frameworks and different components. But if we take only the components that we talked about today, then we can kind of relate it or compare it with the clean architecture that had 3 different layers. Then here we're going to have our presentation layer, which will just contain our Android components and all the view-related code, which is listeners and kind of loading the data on the screen. Then our second layer will contain our view models with the live data objects and some lifecycle-aware components. Let's say if we want to register on, if we have a location manager or kind of a tracker that needs to be binded to the lifecycle events. And our third layer would be our data layer. Here we can use, for example, the repository pattern, which I'm sure you're all familiar with. Then we can have different data sources. We can use some remote APIs if you use retrofit for that, for some web services calls. Then we have our models, and using the Room database or SQLite or SQLite or whatever solution you want to use. And the nice thing about this structure is that, for example, if you want to define some caching strategies, you can just define them here. And for the different layers, or like for the live data and for our activities, it actually doesn't matter if now the data came from the web or from an external API, or it came from a local database, or maybe it came from storage or from a memory cache. So you can actually define all these data strategies or cache strategies in these low-level components, and all the consumers are just consuming the repository, and they actually they don't have any idea where the data is coming from, and actually it's not important as long the data is valid and everything works fine. So as I said, we have our presentation layer, business logic or domain layer, and our data layer, which I think is very useful because especially for Android developers that kind of are starting their way on Android, so Google just defined different components that hopefully in a couple of years, most developers will know, and I think it's a very nice common language for developers that are starting to work together, or if you are coming to a new team. Again, probably for most production projects currently which are not using them, then they're not just going to replace their architecture to use these architectural components. But I think that within time, or like when the time passes, then we're going to see more and more usage, especially of the lifecycle aware and the live data for projects which are not using RxJava, because it's kind of a nice asynchronous solution for that. I think this is it. Thank you. Now we have 45 minutes for questions. No? Yeah. Questions? Yeah? Yeah, you can. In what context? Like,
I mean, if I saw like the view models of something, how you get it, I don't see how you would inject stuff there.
Yeah, so the view model is actually being injected already by the operating system because you have this kind of call. So with the view model itself, probably not. But with the other components, you can just use Dagger as you use in your projects, actually.
There's a view model factory also that you can use injecting inside the view model.
Right, yeah. More questions?
I have one question. So let's say you have some models for the entities in the repository layer and then other models in your business layer. Where would you do the mapping? So obviously if you put this mapping in the upper layer would know about some models in the repository and other way around. So
right.
How would you,
Yeah, actually it's a good question. I guess as long as you're persistent about it, it doesn't really matter. So if you decide that you want to do the mapping on the middle layer, it's fine, but then make sure to make all the different, like this kind of mappings there, just to kind of be persistent in your architecture, basically. In most cases, probably I would do it in the data layer. So I will expose only the absolutely necessary minimum data models to the UI or to the middle layer as well, because in most of the times, the models that you're actually presenting on your UI are much simpler than the data you are storing. And you don't need more. The only thing you need is kind of a identifier if you want to manipulate some of the entities. But I would try to go with the minimum as you can, basically. So I would probably do it here, like in the lower layer. Anything else? Yeah.
Since app component stuff since 26.1, you said it includes the lifecycle aware component, so we can actually, if your project is on that, we can just use it, right?
Right, yeah, right. So from 26.1, you don't need to add any dependency for the lifecycle aware components, but for the LiveData and the ViewModel and Room, there are different dependencies. I just checked today the method count because it's always like an issue, you know. For example, somebody knows like what is the method count for Rx Java 2? Do you know, like it's like hundreds of methods or thousand? I'm not sure. So thousands, right? So from what I saw, all the dependencies together. So if you're using lifecycle aware, as we said, from 26.1 app compat, it's already in. So anyway, you can use it, you cannot use it, it's still in, so it doesn't matter. But all the different, like the LiveData, the ViewModel, and Room together, I saw it's like maybe 600-700 altogether. So it has a relatively low method count, which is actually positive, I guess. And like Rx Java is very, very functional rich. So there are a lot of operators there. But again, most of the use cases, most of the apps don't use all these kind of operators. So except of filtering, merging, and mapping, probably you don't use all the other stuff. So this is kind of a lighter version of a framework which lets you register on asynchronous data updates.
One more question.
Yeah.
There's like an annotation for ignoring
Right.
a certain field. If you use this entity only for the scope of your database, what would be a valid usage of this ignore? Why would you have this price field if you anyhow ignore it?
Maybe you have some, so one use case would be that maybe you want to compute some attributes. So let's say you want to compute the price after you fetch and then update this attribute. So you don't want to, you're right, in most of the times like it's not going to happen, right?
When you have a bitmap, for example.
Yeah, for example, then you wouldn't want to store it, but I would probably prevent of having a bitmap as I would like have the URL or the URI and not have an attribute as a bitmap anyway, but that can be one use case for that. Maybe if you have if you have a need for thousands of, like for very large data set, then maybe you need to think twice. If I really need to persist everything, maybe I would have some trade-off in just computing some of the stuff on runtime. Maybe if it's time-sensitive stuff that you need to compute over and over again. That's it? Come on. You're tired, huh? Not enough questions. I really like this slide. Okay, thank you very much. Enjoy your beer.